We're at the top of page 6 for your chemical quantities unit notes. Now a mole is a unit of measure. Now we can shorten that, and in chemistry mole, M-O-L-E, is shortened to M-O-L. What is a mole? It's this very, very, very long number, which is more commonly written like this: 6.02 times 10 to the 23rd. Please commit that to memory. And we're just going to go through a little bit of a exercise here. How many eggs are in a dozen? And I'm hoping you said 12, so therefore how many pencils are in a dozen? Fill that in. If I asked how many dozen was 12 donuts, you should say 1, which means if we have 12 books, we have 1 dozen books. A dozen always equals the same number. That number is 12. A mole always equals the same number. In this case, it's 6.02 times 10 to the 23rd. Now, one of the things about that is a mole can represent a lot of different things. It can represent particles. Those particles could be atoms. They could be molecules. They could be ions. And this is not exhaustive. It could be more things. It's Avogadro's. It's named after Amadeo Avogadro from the early 1800s. Now, when we're talking about a mole can be this. It can be a certain volume for a gas, only a gas, and it always equals 22.4 liters. If we're talking about mass, 1 mole is the GFM. It's the mass of an element or GFM of a compound, either one. So let's go through. If we have a mole of carbon, that means we have 6.02 times 10 to the 23rd atoms of carbon, which means we also have a mass of 12.011, because that's what we got right off the periodic table. A mole of sodium is 6.02 times 10 to the 23rd atoms, or for mass, a mole is 22.98977 grams. When we're dealing with a compound, it's the GFM. So I'm going to scroll this up just a little bit. Mole examples. A mole of carbon dioxide is the GFM. So to find the GFM, we've got carbon, we've got oxygen, so there's our carbon. Our oxygen is 31.9988. When I add those together, we get 44.0098. So what we can write over here is 44.0098. So do the next example problems.